I'm going to just give you a quick rundown of what a probability is. So, a probability gives us the likelihood or the chance or the probability of some outcome occurring. So, let's suppose that we roll a die. So, rolling a die is called the event. Anytime you roll a die, there are six possible outcomes. You could roll a one, you could roll a two, a three, a four, a five, or a six. And any of these outcomes, right, have the same chances of occurring. So, they're all equally likely to occur. So, we call these outcomes, we call it the random variable. So if I want to know when I roll a die, what are my chances of rolling a one, a two, a three, a four, a five, or a six? We call that the probability, and we can use the notation P of one. So P of one means what is the probability, the likelihood, the chance of rolling a one? And I'll continue writing the notation for all the other possible outcomes. So I want to know what's the probability of rolling a four, or rolling a five, or excuse me, a six. So let me erase that, change that to a six. Okay, so how do we calculate these probabilities? Well, what we do in statistics is we start rolling the die many, many times. So just to save time, let's say I roll it just 20 times. So n equals 20. I roll it 20 times, and I already did this off screen. But when I did that, one showed up 5 times. So that's the frequency. I'm going to record it in the second column. And then in the third column, I'm going to also record the relative frequency. Now remember, the relative frequency is the frequency divided by the total number of trials. So here, that's 20 times I rolled the die. Okay, when I rolled the die more times, two showed up 6 times, so 6 out of 20. A three showed up 2 times, so that's 2 out of 20. Four showed up also twice, so that's 2 out of 20 for its relative frequency. A five showed up once, so that was 1 out of 20 rolls. And a six showed up 4 times, so that was 4 out of 20. Now, when we take a look at the third column here, the relative frequency column, this is also distribution. It's a distribution that shows me how often each of these outcomes occurred when I rolled that dice or that die 20 times. We can also convert these fractions into a decimal. So relative frequency can be displayed as a decimal. And then if we multiply that decimal by 100, we'll get the percent. So when I rolled that die 20 times, 25% of the time a one showed up. 30% of the time a two showed up. Let's see, 2 out of 20, that's 0.10. So 10% of the time a three showed up. And 10% of the time a four showed up. So 1 out of 20, that's 0.05. 5% of the time a five showed up. And then 4 out of 20, that's 0.20. So 20% of the time a six showed up. So this right here is the probability or the likelihood of getting each of these outcomes when I roll the die 20 times. But when we are looking at the probability of these events, we're interested in what happens over the long run. So over the long run means when I roll the die, not 20 times, but many, many, many times. So you can imagine, well, what if I rolled it 100 times? Or what if I roll it 100 million times? Or what if I roll it an infinite number of times? What is the relative frequency going to look like over the long run? So what's going to happen as I roll the die more and more times is these relative frequencies, they're going to change. Like I could roll the die 5 more times, and let's say, six shows up 5 of the times in a row. And so then this 0.20, that percentage is going to start going up, and then all these other percentages are going to go down. So these percentages are going to go up and down as I roll the die more and more times. But the big idea is that over the long run, each of these relative frequencies is going to start approaching the true probability for each possible outcome. So what is the actual probability of rolling and getting a one? What's the true probability of rolling a die and getting a three or a four, a five, or a six? Well, over the long run, we're going to see that the probability of each event depends on, okay, well, what are all the possible outcomes in this situation? There are six possible outcomes. If rolling a one, two, three, four, five, or six all have the same chance, then my chances of rolling a one eventually is going to be 1 out of 6 chances, or 0.17 or 17%. My chances of rolling a two, well, is just as equally likely to happen as rolling a one or a three, a four, or five. So all of these probabilities are going to end up being 1 out of 6. Or you can convert that to a decimal and then multiply it by 100, and we'll get the percent, which is about 17%. So each outcome has the same chance of occurring. So in this third column here, this is the probability distribution. This probability distribution shows us the probability or the likelihood of getting each outcome. Another important thing to note here with probability distributions is if you take a look at each individual probability and then you add them all up, okay, add up all the possible outcomes, you'll see that's 6 out of 6. So the probability of each individual outcome together is going to add up to 1. And the same thing, if you add up all these decimals, okay, that's also going to add up to 1. And then if you look at the relative frequency distribution, which is this third column, you'll see the same thing. When I add up all these fractions, I'm going to end up getting 20 out of 20. So the total probability is a 1. And the same thing, if I add up all these decimals, the total probability is also going to add up to 1. So in chapter 6, we're going to find out that when we take a look at the probability of each individual outcome, right, and we add them all together, the total probability of all the possible outcomes for any one particular event is going to add up to 1. It has to. All the small parts have to add up to a whole, the whole being 1. So that is a really important piece of information when we start looking at probabilities in chapter 6.